All right, we should be live, I believe. Uh, are we live? If we're not
Oh,
live,
okay.
hopefully our hosts will let. Yeah, we're good. Okay. Hello, everybody. So I am back with our next guest, Dr. Thomas Holtz, who is a principal lecturer at the University of Maryland and a research associate at the Smithsonian Museum of Natural History. Um, and he's an expert on all things tyrannosaur, as well as highly involved in the education of the next generation of not only paleontologists, including yours truly. I was an geology undergrad at the University of Maryland, but also students of all aspirations and backgrounds. And he will be telling us about those ballerinas of doom, the tyrannosaurids. And I think I just saw your cat go behind the back.
Um, yes, in fact, Inky is probably, oh, she's going behind the camera, but if I get a quick donation in there, I'll turn the camera on her. Actually, I'll do that anyway. If she's moving
Yeah.
around, there she goes. There she goes
Oh,
on the
yeah,
floor.
yeah. We kind
Yep.
of
She
got it
may pop up
right.
later on. The other cats are older. They're a little less energetic. So,
Right. Oh.
although I suppose for the right size donation, I can go and get Nova. She's rather tractable. So.
I see. Yeah, excellent. So, yes, do keep your donations coming in if you have questions or want to see Dr. Holtz's cat. And yeah, otherwise, I think we can get started with your presentation.
Sure. And so my game plan for this is to do a presentation for the first part of the hour, and then open things up to questions. And they could be questions about the presentation, or about dinosaurs in general, or paleontology, or life, whatever, evolution. So let's see. Okay, sharing. Start sharing. There we go. And so is this coming through?
Yes, I see it at least. Oh, and there's my
Okay.
Anzu.
Okay. Yes. Exactly. So what I'll be talking about are tyrannosaurs, ballerina marathoners of doom. I've had previous lectures where they were just the ballerinas of doom, but in light of a new paper that came out,
Right.
I added in the marathoner aspect. Here's my contact info, including my Twitter handle, so you can join in and see my posts as they come out, which are mostly actually sharing of technical papers, but I do a lot of other stuff. And indeed, here is Albert's Twitter on Zoom. As Albert mentioned, I am both a faculty member at the University of Maryland in the Department of Geology and a research associate with the Smithsonian. I'll have some things to say about the Smithsonian, the new Smithsonian exhibit at the end of this presentation. So who am I? Well, first of all, before we get to that, please donate. I was really pleased to see the dinosaur community of researchers and fans and artists and so forth come together for this important issue. Please do donate. And as the general, it's easy to do. Just look below in the Twitch stream. There's the links there. It's an important issue in general in our society right now, and I'll talk more about that at the end, or say, give a few thoughts. And a particularly important issue in paleontology and the earth sciences overall, where people of African descent, as well as people from many minorities, are greatly underrepresented. And without your voice there, without your insights and opinions, we are lessened. So please donate. Obviously, donate to help boost your questions priority, but also donate anyway. There's some cool T-shirts down there with this logo on it. You want to make sure to commemorate the fact that you joined in here.
Right.
So do that. Okay, so as Albert mentioned, my main job is as an undergraduate educator at the University of Maryland, both within the Department of Geology and within a special program, a residential living learning community called College Park Scholars Science and Global Change, which itself is a descendant of an earlier program called Earth, Life, and Time. And I'm extremely pleased to have had not just one, but two former students who are both former geology students and members of my scholars program, who either have presented and in one case also organized this. So Albert was one of the towards the very beginning of the Science and Global Change program, and Ohania Gold was a scholar within the Earth, Life, and Time program. She presented yesterday, and also an undergraduate student of mine. And we do a lot of stuff in the classroom. Well, we used to, before certain pandemics that started pandemicking, but of course out in the field. So it's important to get students out in the field, whether they are earth scientists or not. Oh, and I should mention another member, a former student in my programs, both in geology and scholars, who's gone on to acclaim within the paleontology field. This is Susan Dramala, the co-namer of Carnifex, the crocodilomorph, the possibly bipedal large crocodilomorph of North Carolina, the Triassic. And beyond just the students who go to the university, I do a lot of outreach in general, and for the general public, whether it's to little kids or student-age people or adults or people, people in fact of all ages. And that actually occupies most of my time. Like Darren talked about before, by doing research, I have to grab where I can. I do get out in the field when I can. Sadly, this summer, I will not be out in the field. This is me with the toe of a specimen of Anzu that's been named Pearl, that we've been collecting in Carter County, Montana, so southeastern Montana. And indeed, for those who either are members of the research community or follow us, you've been hearing the lament of many researchers who have not been able to get out in the field, including Jack Horner was mentioning. It's like first time in 50 years he's not able to have a field season. So the pandemic is affecting us in many sorts of ways. But although I do like to do field work, like a lot of researchers, the stuff I work on is the stuff that's been collected and prepared. And of course, my favorite topic is the Tyrannosaurs, like Tyrannosaurus rex here. So I work on Tyrannosaurids and Tyrannosauroids, and in fact Theropods more generally. And in fact, I published on Dinosauria as a whole. Now, for the handful of people here, but there are probably some people here who are not, hardcore dinosaur fans. I've tried to get the word out to people from all over, so maybe you guys don't know all this detail. Tyrannosaurus is, of course, the most famous representative, but is just one member of a larger group, a family in the old Linnaean sense, called Tyrannosauridae. And honest to goodness, quite frankly, if you aren't really a dinosaur anatomy specialist or even a theropod specialist, telling some of these guys apart from each other is really difficult. They are all skeletally very similar. I mean, Tyrannosaurus rex is the extreme example, but because it becomes larger and therefore its adaptations go to a more extreme. But overall, these things have a very similar body plan. And of course, one of the most famous aspects of their body plan is their incredibly powerful bite. And a recent paper from a couple of colleagues that came out that really looked at how powerful the bite, in particular, of Tyrannosaurus rex was, where they modeled the size of the muscle groups involved in jaw closure. They did it for different individual T-Rexes, because after all, a basic rule of biology is that they're individuals, and you can't a body mass estimate for an individual of any species does not apply to all specimens. The bite force does not apply to all individuals, etc. And they looked at the pressure generation, so not merely the force of the bite, but the pressure generation of individual teeth, and they found tremendous bite forces. So very large individuals of Tyrannosaurus have almost a 35 kilonewton bite force, more than twice that of the largest living modern reptile. They found that the tip of the large teeth could generate forces of 1 gigapascal, so more than enough to blast through bone. And these are different modeling bite attempts on bone and how this might obliterate the structural integrity of the bone that Tyrannosaurus was biting. So obviously Tyrannosaurs are famous for their powerful bite. They're infamous for their dinky little arms, although, as the T-Rex is pointing out here, that might be very helpful in certain situations. So, and Tyrannosaurids in general and their closest cousins are indeed characterized by these shorter arms derived from long-armed ancestors. So it's somewhere in this phase that the arms become reduced. And there's Tyrannosaurus proper over here. But although people joke a lot, and many, many cartoons, either about the powerful bite, well, they don't joke about that, it's serious, or the dinky little arms. And so here we have different perspectives on the weaknesses of the different individuals. There's another part of Tyrannosaurs that are really amazing, and they don't get the attention they deserve, and that's their legs. So Tyrannosaurids are leggy giants. Part of the problem with this is Tyrannosaurids are just so familiar in many people's minds. They are the default large theropod. And so we think of their proportions as being the normal one. But they're not. Tyrannosaurids have unusual hind limb proportions. The other problem is that people tend to focus, and I'm going to say this is going to sound like heresy for me, they tend to over-focus on adult Tyrannosaurus rex. And adult Tyrannosaurus rex is the extreme example. If you look at a typical Tyrannosaurid, the legginess really comes out. So here are comparable sized individuals of Allosaurus, not a Tyrannosaurid, and Tyrannophonius. And in particular, the lower part of the limb of the hind limb of a Tyrannosaurid is very long, very slender. And I've been doing research on Tyrannosaur legs a little longer than many of the people who are watching this have been around. And that has been a big focus of mine, but even though I've been working on it a while, we've had some new information come out in the last couple of years, and that's going to be the primary focus of this presentation. So ancestrally, we know that most theropods have, relatively speaking, broad feet. So here's the foot of Allosaurus, that's digits 2, 3, and 4. Here is the hind leg of Majungasaurus and a Balisaurid. And in contrast, Tyrannosaurids have very long and compressed feet, particularly the middle bone, metatarsal 3, is compressed between the other two. So here is a young individual of Gorgosaurus. Here is a relatively mature individual of Tarbusaurus, the closest relative to Tyrannosaurus for which we have a good skeleton. And back in the, well, technically back in the 80s, but not published until the 90s, I came up with the term Arcto Metatarsus, or compressed metatarsals, for this sort of foot condition. And just to show a little bit of anatomy, here's a specimen of Daspletosaurus, yet another Tyrannosaurid. And there's that middle bone. It's not a column in Tyrannosaurids. It's compressed at the top, and it fits between the other two. And it produces this long, slender, interlocking metatarsus. That is not unique in having the arctometatarsus. For instance, the ornithomimids, the toothless members, or some of the toothless members of the ornithomimosaurs, the larger group, also have an arctometatarsus, like Ornithomimus and Gallimimus and Struthiomimus and so forth. And long ago, I showed statistically, and other people had noticed prior to that, that those dinosaurs with an arctometatarsus, like ornithomimids and tyrannosaurids, tend to have a longer metatarsus, a longer foot, than a typical mainline theropod. And consequently, that's where a lot of the length of the leg comes from. The tibia might be a little bit longer in a tyrannosaurid than, say, as compared to an allosauroid of the same body size. But the metatarsal really makes that longer leg, and it's associated with that compressed form. And I and others have speculated over the years on different functions, as a shock-absorbing function or the resistance of torsion. And it's from this work by Eric Snively and Russell that one of the first papers I'm going to talk about came out. And that is the question of, did the arctometatarsus allow tyrannosaurids to be more agile than other theropods. Well, in fact, Snively and Russell suggested that the Arcto-Metatarsus did, but did the rest of the anatomy show an increased level of agility for Tyrannosaurids compared to the other big theropods? So this paper came out a couple of years ago. We had been working on it for a while. You see, it's got quite a big list of authors on it. We all contributed in our own different way. And in fact, the figures, I'm going to have a shout out at the end to my colleagues who produced some of these great figures here. So how did Tyrannosaurus, and here's Tyrannosaurus shown with the asterisks, how did its agility compare to those of other big theropods? So how do we estimate agility? Well, that's what we're going to be looking at is angular acceleration, which is torque, so the forces generated to do turning, versus the rotational inertia, the resistance to turning. So how do we estimate these? Well, the first thing we want to do is estimate the rotational inertia. And the way to do that is to do sausage slices, which is strange, but that's kind of what we do. So we took high quality reconstructions of a number of large theropod dinosaurs, and we rendered them, and by we, I mean some of the younger colleagues, I didn't do this part, rendered them into these little frustra, which are basically like sausage slices. And for each of those, we got the density properties and therefore its rotational inertial properties, and then integrated it over the whole anatomy. So we did that for several different dinosaurs. The different parts of the anatomy were given different densities based on our interpretation of how much bone versus muscle versus airspace versus what have you was present in each section. Now, we wanted to double test that the mass values we were getting were approximately similar to those estimated by other researchers using other techniques. Now, ideally, we would like to see that our mass estimates were accurate compared to the real thing, but we don't know what that is. So we had to sort of, how much coherence does it have with previous work? And comparing to some laser scan estimates done in the past, we found that our values were fairly close. In fact, they encompassed the best estimate values from this paper by Bates and colleagues. And we found that the center of mass that we found in our estimate was only about 3 centimeters off. That's, for us Americans, that's just a little more than an inch off. So for the purpose of our study, we felt that these were really, really good estimates. Now, how about the torque? To look at this, we looked at the size of muscles associated with the ilium and with the tail attachment, with the tail. Those are going to be the major muscle groups that would be able to generate that twisting force on the body. So we traced out those areas. We mapped out the fitness of the tail muscles under a couple different models. And so then we worked out 2 different scenarios. Our first scenario was the body swinging on a single foot, so pivoting around on a single foot turn, sort of like a ballerina, hence the name of the ballerinas of doom. The other one was both feet planted and turning around. In these different situations, different amount of the muscle groups would be able to be employed. And people had already noticed that, yes, tyrannosaurids are characterized by relatively long ilia, and also deep and robust tail centra, the middle body of the vertebrae, and therefore had a larger area for muscle attachment. Another point is that, and not shown here, is that from the top view, the ilia of tyrannosaurids come really close to each other. And that's not like many other theropod dinosaurs. And Jurassic Park modelers, I'm looking at you, you get this wrong. So that's okay. It's cool movies and so forth. But the iliac blades should be very close to the middle on a tyrannosaurid. Anyway, and so we worked this out to develop an index of agility, and here's the equation for that. But what's the point? After all this math, what did we find? Well, for the specimens we looked at, so this would be on the non-tyrannosaurids that's Eustreptospondylus, up to Giganotosaurus. And this is a juvenile Gorgosaurus libratus up to Sue, the big Tyrannosaurus rex specimen. And at every body size, the Tyrannosaurids had about twice the value of agility, the agility index, than the large-bodied non-Tyrannosaurid theropod. And this is the data looking under with both feet planted. Here are the estimates with standing on just one toe. So we found overall, yes, Tyrannosaurids seemed to be more agile than other large-bodied theropods of the same size. So they could turn more quickly. Now, why might that be? One aspect of that is, as opposed to some of the earlier types of theropods, the community of potential prey items that Tyrannosaurids were going after were themselves more agile and, quite frankly, more brainy prey. These would be things like hadrosaurids, duckbill dinosaurs, and ceratopsids, horned dinosaurs, as opposed to stegosaurs and sauropods. Of course, a flip side is being more stable, so maybe not turning around so much, but with both feet planted on the ground, that actually might be more useful for animals going after these giant walking walls of meat. And of course, to be fair, normally they're not going after full adults. They're going to go after juveniles and so forth, but still, you know, a half-grown sauropod is still an awesomely huge animal. So that was our look at agility. What about that other basic factor of Tyrannosaurus, and that is the total longer hind leg length? Did the longer legs in big carnivorous dinosaurs, in particular Tyrannosaurids, actually increase their speed? That had been the default assumption. A basic premise in a lot of morphological looks at the anatomy of organisms has been that longer hind limbs tend to be correlated with higher speeds. Well, because we think of longer hind limbs as being cursorial, that is, running adaptations. So a paper that came out earlier this year that I was involved with, but again, many contributors, and I have to point out, Alex carried the lion's share of the work here, looked specifically at the contributions of longer hind length with regard to a couple different factors in terms of locomotion. Now, I'm going to be focusing here on the large theropod part, but we also looked at small theropods in this study. Now, one thing is, what about maximum speed? Well, I would say estimating maximum speed right now for extinct animals is sort of a fraught process. We don't really necessarily know all the factors that contribute to maximum speed, and slight tweaking of variables can give you radically different values. What we did is use a couple different types of parameters to estimate the maximum speed, as well as what speeds these animals would be moving at dynamically similar forms of locomotion, so using Froude numbers, dimensionless speed values. So this is just showing, actually, on this curve, we see that Brian Eng put together, using our original data, different animals today where they would fall on some of these curves. But as people should know, and most of us do remember, there's more to being cursorial than just maximum attained speed. I mean, that is an aspect. How fast can you go? But there's also acceleration. Maybe the maximum speed isn't the thing you're going for, but the ability to get up to speed. Or maybe it's something having to do with more about increased home ranges. And then on top of that, having long legs can have other functions. I mean, they may be related to habitat, or they might be related to your feeding style, or who knows what else. You can use lots of stuff with long hind legs. And in fact, what we found is that the longer hind legs of adult Tyrannosaurids, Tyrannosaurids greater than 1 ton, tended to have only marginal increase for maximum speed. There's too many other physical factors that are keeping the animals from getting tremendously fast. But it did have a notable decrease in the cost of transport. And so Tyrannosaurids, I would expect an adult Tyrannosaurid is still going to be faster than an adult Allosauride of the same size. But the contribution of the decreased cost of transport is probably more important. They're able to cover more territory without expending as much energy, and therefore that's going to lower the amount of times you're going to have to kill something, and therefore live at a more efficient lifestyle. And so if you think about it, cursorial is a running adaptations, but as those of you out here, not me, those of you out who are athletes well know, there's more to being runners than being sprinters. Yes, sprinters are runners, so are marathoners. Marathoners are runner too, and maybe their maximum speed isn't as great, but they cover greater distances. So this is the TLDR version of our paper. So for small forms, it looks like longer leg does really help, mostly with speed, and that, yes, probably is involved somewhat with hunting, but also smaller theropod is on other animals' menu, so being able to escape is more useful. Giant theropods less likely to be on menu, at least at adult body size, but being more efficient may have been its advantage. But something to keep in mind is that these adaptations, although they may have functioned to decrease cost of transport, and they may have functioned to increase agility, did not necessarily evolve in the context of large-bodied theropods. And in fact, recent discoveries are beginning to shed light on an important transition in the history of the Tyrannosaurids, that many aspects of the Tyrannosaurid body plan appear prior to Tyrannosauridae proper, when the animals were much smaller, at least as far as we can tell. So Susquityrannus, who's shown here, restored, and Moros, two recent discoveries from the earliest late Cretaceous of Western North America. Neither of them terribly complete, but they do show evidence that many of the Tyrannosaurid adaptations evolved at a smaller body size. Incidentally, these two papers came out, they were both in process at the same time, although to be fair, the Susquityrannus paper has been in process for well more than a decade, or had been in process for well more than a decade. Yeah, so cool stuff that came out. So here's a restoration of a likely, the size of perhaps even an adult Moros. Not an animal that we'd like to encounter on a daily basis, but as far as the ecosystem in which it lived, is not an apex predator. It's a small-bodied predator, and yet seems to show the same hind limb adaptations that we see in the giants. I like this figure that Sterling did. Here's the remains of Susquityrannus compared to just the dentary, the front end of the lower jaw of Tyrannosaurus rex. And yet even here we've got the Arcto Metatarsus. Mm-hmm. So it looks like the increased agility and the longer hind legs were adaptations that were showing up in small-bodied forms in the context of lower on the trophic level, minor components of the fauna, but already there, so that when Tyrannosaurids did attain the giant size in that last part of the age of dinosaurs, they had a suite of adaptations that could help them move in ways that we hadn't seen before among large theropods. Okay, so a few things before I turn it open to the questions. Last summer, the Deep Time exhibit at the Smithsonian finally opened up, and it's a great exhibit for those who had a chance to see it. It's organized chronologically for the most part, but because they've literally knocked out the walls, non-supporting walls, they've knocked out the walls of the old hall, you can stand in one spot and see giant Jurassic dinosaurs and latest Cretaceous dinosaurs and Paleogene mammals and Neogene mammals and Quaternary mammals and so forth, all in the same hall, and get a sense of their relative sizes and proportions and so forth. It's a great exhibit if you ever get a chance, when you get a chance to see it in person, but of course, because things are shut down right now, you can't see it in person. But you can take a virtual tour, not only of the Deep Time halls, but indeed of all the exhibit halls of the National Museum of Natural History. And so here's the URL. I sent this information to the mods, so hopefully they can post it in the chat if you want to go check that out. Similarly, speaking of stuff available online, I've always tried to put my lecture notes for my undergraduate courses available online. Here is my dinosaurs, my main dinosaurs class, GL 104. Here's my fossil record course, which Albert was a TA for at one point. And so you can check those out here. Indeed, this year, I had started, even before the COVID crisis had shut things down, I started recording the videos of my lectures for the fossil record. That became even more imperative with the shutdown. So if you want to go check them out, they're available here. And again, I put these, made these links available to the mods, so they'll be able to post them in the chat. Special thanks to my colleagues who provided those slides from the agility paper. And of course, for thanks for being part of that really fun and excellent project. And remember, please donate. This is a really important issue. I'm closer to 100 than I am to 0 these days. Not much, but a little bit. And issues that, sure, in our rarefied world of research, we might think, oh, those things have all been taken care of when I was a kid. No, they're not. No, they're blatantly not. These are important issues that need to be dealt with. Please contribute as you can. As I said before, we need Black lives in our dinosaur community of faculty and curators, graduate students, of undergraduates, of young people, of paleo artists, of fans, and of course, not just Black lives. We need everyone's point of views, but that's the important issue that we're here to talk about today. Please donate. Again, donations can help boost your questions up, but donate in general. If you want this logo on a T-shirt, that's available down there. The profits go to BLM. And I thank people for tuning in. And now I will be available for questions once I remember to stop sharing. All right, there we go.
Yes, fantastic talk, Dr. Holtz, as usual.
Great, thanks.
Yes, so while your talk was ongoing, we did receive a few questions coming in. Hopefully we will get more. Let's see. The first question is, Dr. Holtz, I'm super jealous of your ability to find the incredibly diverse array of papers you post on Twitter. So my question is simply, how do you do it? And are there any tips to develop a similar paper finding system from Gary?
Oh, that's a good question.
Yeah.
Actually, I rely, it is the network related nature of our modern online existence. Some of these I come across myself, but by and large, I'm seeing other people finding some of these, but I have multiple such people that I'm following or whatever. So some, for instance, are posts on the dinosaur mailing list, which still exists for those people who are. And so I'll find those and post those out. I'm on comparable other listservs for other paleontology and evolutionary biology groups. Also, I see other people posting interesting papers on Twitter, and therefore I'll go check them out and forward them on. So by having the contacts out there to see what's coming out, that helps to get the information out there. And quite frankly, and this is for paleo artists, for paleo fans, and especially for paleo students and researchers, actually not just paleo, just researchers and students and so forth. Make sure you tune your awareness of research quite broadly. Yeah, I know some of us might want to, I just want to see like dinosaur papers or theropod papers or, whatever. No, keep an interest in all sorts of things. You never know what paper you come across that might really give you important insights. And, without which, your particular research or your particular art, whatever, would be, wouldn't come off as well as you intended. I mean, just to use the most grandiose example, think of what would happen if neither Darwin nor Wallace happened to read the demographic work by by Malthus, by Thomas Malthus. there's no reason to think that either of them would have said, we want to find out about human populations and economy. But if it weren't for both of them independently coming across that work, they would never have discovered natural selection, or they may have discovered it, but it would have taken them a longer time. So keep your eyes open towards all sorts of research that's out there. You never know what thing might actually spark some great new idea.
Right. That sounds like excellent advice, and definitely as someone who also tries to keep up with paleo-related studies, I can definitely confirm as well that casting a wide net in terms of just people you follow and the studies you look at can be very helpful in keeping up to date on these matters. For completely unrelated reasons, I was looking through the Dinosaur mailing list archives the other day, and I actually saw an old message where someone was complaining, stop posting papers that are not about dinosaurs or something like that. And it's like, no, these papers are still relevant to dinosaurs. They may not be directly about them, but it's good to maintain an interest in those other subjects like Mesozoic plants and mammals and ecosystem functions in general.
Yeah, and I think this is something to throw it out there too, is I get a lot of people who will ask me, how do I become a paleontologist? And I could go over that if people want to, but is the question, do you want to become a paleontologist or do you want to contribute to paleontology? And those are two different things. As you saw in just those two papers, three papers if I include Paul and Greg's paper, there's a lot of math involved. You can be an engineer or a mathematician or a statistician and contribute important stuff to paleontological research. Obviously, we need the geochemists out there. We need the people who work on modern zoology and modern animal behavior. And that's just on the research end. We think fieldwork and preparation, outreach, art. Almost anyone has something they can contribute to the world of paleontology, even if they aren't a degreed research paleontologist.
Right. Okay. Let's see. We have a couple of questions with donations from the same person, but one of them should be pretty quick to answer, so I'll give you both of them. So the first, probably longer question is, according to your interpretation of the data, do you believe Megaraptorans were Tyrannosauroids? And the second, probably easier question is, have you heard of Homestuck?
I have heard of Homestuck. I haven't really ever followed it. I know it exists, but it's there's only so many bits of media out there that I can sample, but I do know it exists. As a for Megaraptorans.
Yeah.
Ooh, that's a darn good question. Maybe. Kind of. Maybe they're Tyrannosauroids. Maybe. I would say they are almost certainly basal Coelurosaurs, like as Tyrannosauroids are. And the real question right now is, are they a branch of basal Coelurosaur that branched off before the Tyrannosauroid Maniraptoran split, or Maniraptoriform split? Or are they actually an early branch of Tyrannosauroid? And one of the problems is that part of the tree, that sort of the three major branches, aren't super well sampled right now. And additionally, many of the taxa down there are small bodied sized. And when you get some of these small bodied basal Coelurosaurs, quite frankly, they all tend to look a lot like each other. And so sorting out their actual relationships can be a bit tricky. I mean, even today, what is the composition of Compsognathidae? Who knows? Are they all close to each other? Or are they spread out? I wouldn't be tremendously surprised if Megaraptorans turn out to be Tyrannosauroids, but I don't know. I wouldn't consider it to be a data decisively superior position right now to the idea that they branched off earlier.
Right, makes sense. Yeah, it's one of those kind of a specialized group, and you're trying to compare it to more generalized potential ancestors, and it's very difficult to tease those relationships out when you get that kind of situation. Let's see. So another question that has been going on in the chat is that there has been some discussion on the validity of Gorgosaurus as its own genus. What is your take?
Well, what's a genus?
Right.
That's really it.
Right.
There is a big enough problem as to the answer to the question, what is a species? Literally, it's called the species problem. You take that up a level. What is a genus? A genus is a term that we use for a cluster of species that we like to use. So, is Gorgosaurus, should Gorgosaurus and Albertosaurus be split from each other? Maybe. Back in the early 2000s, I was very favorable to keeping them separate for the primary reason that at least a few phylogenies did not find Gorgosaurus and Albertosaurus as each other's closest relatives. And to be fair, Lewin et al.'s study some of that matrix will occasionally find them not as each other's closest relatives. And in that context, calling them the same genus is misleading because that would imply that they're related to each other in a way that closer than they are to other theropods. I would say my interpretation of the data is that they are each other's closest relatives, and one could easily envision including, a version where they're both in Albertosaurus. By the same logic, one could say there's no reason not to call Lythrinax and Tarbusaurus and Zuchenotyrannus and so forth Tyrannosaurus. Mm-hmm. There's no reason why, if people want to call Gorgosaurus and Albertosaurus the same genus, a perfectly legitimate thing to do, not to include those members of the close cluster to Tyrannosaurus proper, all in Tyrannosaurus, sort of a Greg Paul style. And quite frankly, a paleomammologist would have done that. Right. It's just that we in dinosaur paleontology tend to calibrate our genericometers at a very high level of sensitivity.
Right. Yes.
It's like a similar thing, calling all the nose-horned Centrosaurus is actually technically not an illegitimate thing to do. Mm-hmm. It's just not the practice that we'd have in dinosaur paleontology.
Right. Yeah. So.
I see someone point out they're all Dinodon. Yeah, there we go, yes. Yes. Fair enough.
Okay, let's see. Someone donated asking what your favorite food taxon is. So referring to your taxonomic scheme of dinosaurs.
Right. Well, okay, yes. For those who aren't aware, my particular taxon scheme is that the basal members, that you have ornithischians and sauropodomorphs, which are the food taxa. Then you have the zone of majesty, which are the non-avian, or at least non-ornithotheracine theropods are the zone of majesty. And then by the time you get to the stump-tailed, swell-tailed flying mutants that are ornithotheracines, that is birdie birds, then they become, birdie birds, and they're less interesting and less majestic. Okay, that's not actually true. So my favorite members of the ornithischians and sauropodomorphs, I would say, it's got a Lancian bias here, ceratopsids and hadrosaurids. And in particular, I would say specifically Triceratops and Edmontosaurus. I think Edmontosaurus, especially Edmontosaurus annectens, is actually a very elegant animal. Yeah. And I think a lot of people don't appreciate that. And Triceratops is awesome. And any animal that can survive and live to tell the tale encounters with adult Tyrannosaurus rex is worthy of our respect.
Absolutely. Yes. Good choices. Meg wants to remind you that they highly object to this. They like ornithischians. So, but but nonetheless, those are very good ornithischians.
Yes.
Let's see. There is a long question, another two-part long question here. So potentially the last question, but we'll see. So the first part is this is from Kat McGuire. I'm working on a large-scale research project on Hell Creek and Lance formations. We have a disagreement on whether Dryptosaurus was present. I thought it was only an eastern species, but one of my co-authors disagrees.
That is intriguing, and I would be interested in seeing who would argue that Dryptosaurus was there. Um, you probably can find in old literature, by old literature, I'm talking like probably 19th century and earliest 20th century, records of Dryptosaurus out west. But those are just reports of Tyrannosauridae, before Tyrannosauridae was named or before it was recognized. I mean, after all, the type specimen of Albertosaurus was called a specimen of Dryptosaurus for some time. Actual, honest to goodness Dryptosaurus in the western states, that would be a really impressive discovery, and to my knowledge has not been documented. By the way, here is Inky. Let's see if I can turn this on.
Right.
There we go. Hi, Inky. Hey, Ink. She's watching the bird feeder out there. Inky is our newest cat. So she actually, her mama still lives in the area. Oh. She's a stray, and we managed to get Inky in, and we had her mama was spayed. So
right. Let's see. And the other part of their question was, what are your thoughts on Oblisodon? I've heard some mentions of it being exclusively juvenile material. So is it a juvenile Tyrannosaur of some kind?
It's almost certainly a juvenile, and indeed not merely a juvenile teeth that aren't particularly well preserved. Right. That have been through some wear and tear, in some cases maybe even digestion. Yeah. You go to some of my old papers, and I'm referring to Oblisodontae, and I refer to Oblisodon and so forth. That's Bistahi everser now. Right. So that was considered the best specimen of Oblisodon for a while, and no, it's not. So some of those really old names, they had some traction for a while, but now that we have skeletons to go with the teeth, we could see a lot more data. Like other theropod taxa, we can talk about Troodon.
Right. Yes. And they clarified in the chat that the claim about Dryptosaurus being in the Western North America is from Estes 1946. So old paper. Yep.
Old paper. Yeah. At the time, there had been no real good detailed study of Dryptosaurus since Cope. Right. So, it wasn't until Carpenter and his team re-examined it in the 90s, and then, of course, Brasati and Carr and colleagues, was just the two of them. Wow, memory's going. They're a much more recent examination.
Right. Okay. And somebody asked, were you consulted regarding the new T-Rex exhibit at the Smithsonian?
No, I was not actually. I wasn't actually consulted on the new exhibit, which was a shame, but that's okay. They had an awesome team of people involved, and I'm quite pleased with the results. The Smithsonian now has its own actual real specimen of Tyrannosaurus on display. It, in fact, is a specimen that's been on display plenty of other places. In the MOR, so former MOR specimen that is now a USNM specimen. So for those who don't know all the logo, MOR Museum of the Rockies in Bozeman, USNM stands for United States National Museum, which was the original name for the museum part of the Smithsonian Institution, but the building is now called the National Museum of Natural History.
Right. All right. Let's see. I do have a bit of time before I have to fetch our next guest. So if any of you have additional questions, maybe we might have time for a quick one. But otherwise, how about let's tell us what you've been working on recently, Dr. Holtz, like research-wise or teaching-wise, anything.
Sure. Well, one thing is neither research nor teaching per se, but we are working on edition 3. And in fact, I'm a little late on getting my contributions in, but it will have the Complete Dinosaur edition 3 will have a very different structure than the previous ones. We're coming in. We're coming in slower than we thought, but that's the nature of book publication. Yeah, Darren actually mentioned that to some degree. And when you start having collaborators, that's even more so. We're on a faster track, we hope, over total time than the third edition of the Dinosauria, which is also coming out, which I'm not involved with this time. So I'm interested in seeing what's coming out with that.
Right.
So no definite publication date for third edition. We need to get all the contributions in, but hopefully in the next year-ish. I would hope to have it in press sometime in 2021. And then from that, once you've submitted it, then it's still this good old world of hard copy stuff.
Right.
It takes some time for it to actually physically come out.
Yeah.
The newest paper of both Darren and mine that came out earlier was the Phylogenetic chapter on Theropods, which we wrote like a decade ago or something like that. Although we did some updates since us and several other colleagues involved with that.
Yeah.
Let's see. I am finally working on have come back to my paper on ontogenetic niche shifts and paleoecology in Tyrannosaurids as compared to other large theropods.
Yeah,
that presented on that back in the early 2000s. I had a couple book chapters that involved with that, and in both cases, the books that is involved with, sadly, did not come out. But there's now been new information on numerous aspects of those analyses that mean it'll be a little fresher, a little more up to date. I also have my my work on the phylogenetic distribution of body integument on dinosaurs. A different approach than the recent. I don't know who else. Barrett's Campani and Evans.
Yes.
Yeah. And the punchline is, for those who've seen versions of the talk as I went around, I gave it for the North American Paleo Convention last summer. The analysis hasn't radically changed. The result is, we don't know. Or rather, it really is strongly contingent on basic parameters, especially whether or not we consider what pterosaurs have homologous to what dinosaurs have.
Right.
That even figuring out what the basal condition is doesn't really tell you what all the individuals are, because, hey, guess what? Evolution happens.
Yeah.
So,
we need that Triassic lager stuff.
Exactly. The Triassic lagoons and the Triassic lakes, go out there and find them, people. And let's see if we can find a fuzzy sauropodomorph.
Right. Excellent. Let's see. So, I don't believe we have any new questions coming in so far. We have about 3 minutes left, so if there's any that come in within that time, I'll let you know. But otherwise, thank you so much for participating in this, Dr. Holtz.
Sure.
Pleased to
and
have
remember to donate. Everyone, remember to donate.
Yes, remember to donate. Do get your donations and questions in. So after this, when we reconvene, it'll be a block of the people I currently work with at the Daniel Fields lab over here in Cambridge. So my lab mates and eventually my supervisor, Daniel, we all work on bird evolution, but different aspects of it. So stay tuned for that.
Okay, great.
Yeah, if anyone has any questions for Dr. Holtz, do get them in 3 minutes, or else we are going to stop this stream temporarily. Okay, there is one.
Good.
What are your thoughts on the influence of the disappearance of sauropods on the disappearance of Allosaurids and the rise of Tyrannosaurs in North America, I assume?
Okay. That is a good question. The sound cut out for a little bit, but I think I got the gist of it. What about the disappearance of large sauropods in North America and the rise of Tyrannosaurs?
Right, yeah.
That's a really good question. That's about an interval of time, sadly, we don't have a lot of data about. One possibility is that for whatever reasons, the large sauropods die out in North America. That takes out the Allosauroids, who have been their primary predators. And with the extinction of the Allosauroids, it allows the small-bodied Tyrannosauroids to become Tyrannosaurids. So that's one possibility. An alternative might be that tyrannosaurids show up in North America and kick the butts of all the sauropods. But given the fact that even medium-sized sauropods like Nemegtosaurus can live side by side with tyrannosaurines, and Alamosaurus could live side by side with Tyrannosaurus rex, I think that's less likely a possibility.
Right.
So I think if they are related, they're related to a larger phenomenon of this turnover for which we really don't have good evidence yet. Is there an extinction event? Is there an event, or is it some long transition? And that remains one of the great undiscovered one of the undiscovered aspects, one of the mysteries of dinosaur paleontology.
Right. All right, makes sense. And that seems like a good place to leave off. So I will stop the stream momentarily.